So today is day 2 of Power BI, and in the previous part we did some introduction to Power BI. Today we will learn how to connect our first data set. The data set that we are using for our today's discussion is called sample superstore data set. Okay. This sample superstore data set, as the name suggests, is the data set uh, where you have orders. Okay, and it's a data set of about 10,000 rows, you can see here. Okay, now in the data set what we have is we have three different sheets, 1 2 and 3. So these three are like three tables of our database. Okay, and all these three sheets are related with each other, which we will discuss how they are related just after having a basic discussion. And this data set that we can see here, so this is sample superstore sales data set from Tableau itself. Okay, so sample superstore Excel file can be downloaded from here, that is this file. This is information of a superstore, can be any superstore, and where in every row we have information of one order instance. For example, you can see here that this is one order. These two rows are one order, right? Or in this case, you can see these 8 rows are one order where the order ID is same. Is it clear? So, right? So this is instance. For example, when you go to a superstore, it's not necessarily that you will buy only one product in one order, right? So what you will do, you will simply go there and you may order n number of different products. So here, for example, this user has ordered 8 different products, and those 8 products are what? These are those products product ID. It can be something, SKU, right? A stock keeping unit of the products. And this is category of the product, like to which category those different products belong. Some of them are furniture, office supply, technology, etc. Then here we have product names. Okay, like Eldon, Expression, Wood, Naval 322, etc., etc. A Xerox machine. Then how much quantity did we order, right, of each product. So for example, we ordered Eldon, Expression, Wood and plastic something. So we ordered 7 of them, or this particular user ordered 7 of them. Did the company give them any discount? Yes or no? It is given there. And how much profit did the company make after this sales? It is given there, right? So for example, obviously your sales and profit are already given. Otherwise, if your cost price, if your sales price is given and your discount is given, then you can calculate the profit also. So we will do another data set. So now you can see, for example, here we have this, right? So we can calculate, we will do another data set, which is financial sample data set from Power BI, where we will have those kind of financial values. Now in this data set you will see we have the entire some demographic information of the customer. We have what is customer segment, what is customer's country, city, state, postal code, region, okay, category, subcategory, etc. Is it okay? So whenever you will get a data set, you will get some values or some fields that are categorical. This is a categorical field, like what was the shipping mode of that particular order, right? When we delivered that order, what was the order date, what was the shipping date, right? Then for customer ID and customer name is also given. Customer segment, is also given, which is a categorical field. Country is also given, city is also given, state, region is also given, which is a categorical field. Okay. Now earlier, if you remember, when we were discussing a few things, so we discussed that a data, when we talk about data, so here we are talking about every field that we have here. Is it okay? When we say a data, that means we are talking about each and every field here. So what is data in this sheet? Order ID can be a data, order date can be a data. Okay, and that's why data type is there, right? Data type is there. What are some common data types? Like in many programming languages, string is a data type. Float is a, yeah, numbers can be either float or decimal, right? Numbers can be whole number or integer, right? So these are different numbers. A string is what? A string is a alphanumerical value. Okay, it can be alphabet, it can be a combination of alphabet and numbers. So it can be alphabet, a combination of alphabets and numbers, right? For example, here if you will see order ID, so in order ID we have both alphabets and numbers. This is alphanumerical field, a string. Here we only have alphabets, Claire Gute, the name. So this is also that, right? So string is alphanumerical, float, integer. Then we have date. One of them is date, and another one is date time. Okay, sometimes date will be given, sometimes the date time will be given. So you have to understand that, right? So these are some common data types that we have. Then sometimes the data will be a Boolean data also. In case of Boolean data, it can be a true false type of data. Okay, data can, let's say obviously data is given as an integer, but in integer we can also have a binary data, right? Only 0 and 1 is given. So different, for different programming language, different cases, data can be of different types, which we are considering here. So this is one classification of data. So here, why we have chosen this data set? We have chosen this data set because we have almost all data types here, all important data types here. Now one important discussion yesterday was, like, on the basis of classification of data, we said data can be a qualitative data, right? Types of data, qualitative, and data can be a quantitative data also. Okay, so data can be, let me show you a presentation. So here we have a simple presentation where we have definition of qualitative and quantitative data. Information that cannot be expressed as numbers. Okay, can we do numerical, can data be counted? Like, yes, we can do counting of how many different type of values are there, but you cannot do a numerical like counting for it, right? Data type, words, object, picture, observation, symbol, string values, right? Those can be the data types. In quantitative data, data can be expressed as a number and can be quantified. Can it be counted? Yes. Can it be summarized? Yes. Can we apply aggregate functions on them? Yes. And data types can be numbers and statistics. So this type of data, we have some example, like if someone's name is given, right? Like Ram, Shyam, John, Mohan, right? So it is qualitative data. So here, if someone's name is given, a segment of that person is given, like to what segment that person belongs, right? To what country, what city, what state, what shipping was used to send, what region that person belongs, etc. are that. If we have some objects attributes, like that objects smell is buttery, fruity, sweet, or something, right? So we can say it's a qualitative thing. We are providing that. Sometimes we define someone with attributes like tall, handsome, smart, etc. Right? So that is qualitative data. Quantitative is someone's marks, mass of an object, right? So when you will see in quantitative data, mostly units will be there. Physics units will be there. You know, we learned those units in physics. Like suppose I say mass of the object is 200. Then you would ask me, okay, 200, but 200 what? Grams, kilograms, etc. Right? So when we tell that these units are there, so sometimes units are there, sometimes without unit we can say that in my company there are 9 people, there are 9 employees, right? So 9 is just a just a count, just a unit. I will never say I have 9 kilogram people, right? I will never say I have 9 centimeter. I will not apply any unit there, right? So sometimes in data we don't apply units, and that's why if you further classify, like data, as you can see here, can be qualitative, quantitative, and even qualitative data can also be further classified into two parts. Okay, the qualitative data can be nominal and ordinal. Is it okay? It can be a nominal value and an ordinal value. So it can be a nominal and ordinal. So you have to remember this today, and we will see in our data set what are there some nominal and ordinal cases or not. So but before that, let's do all the numerical values. So what is discrete data? Qualitative and quantitative data can be discrete and continuous. Discrete means what? Let's say I will ask you, how many phones do you have in your house? So you will say I have 5, 4, 3, 2, right? If I will ask you in the company where you work, how many employees are there? You will say I have 100 employees, 200 employees, 1000 employees, something. You will never say I have 1.5 employees, right? You will never say I have 2.75 phones with me, right? Obviously, because it's a complete unit in itself, right? I have 3 laptops. So discrete data is something where you you explain data like that. So for example, here if a person orders something, so the quantity, like whole quantity, how much they are ordering is this. So in this case the quantity is given as a discrete value, right? Because here we are not ordering 2.5 etc, because here we are not using any units here. And if suppose when we go to a grocery store, we may buy a quantity of 1.5 kg of wheat or 1.5 kg of sugar, right? But in that case we also have to specify, okay, for this quantity what is the unit. Let's say you have written 1.5 here, it is kg, it is gram, what, right? So if no unit, nothing is given, this is like a discrete value. So you can see some examples, right? In the similar way we have continuous, right? Let's say I ask your height, I ask your weight. So it can be anything, like you can say my height is 170, 180 centimeters, right? Whenever you will tell me your height, you will add some unit with it. My height is 6.1, so 6 feet 1 inch, right? Something like that. So whenever you will say, or what is your weight, you will say my weight is 100. Now 100 what? Pounds or kg? An American will be confused, right? So that's why those type of values where a unit is very important to understand the whole concept, like understand that value. Like this is my own way of understanding, right? It is not like it may be the best definition, but it is a easier way to understand. Like if we have to apply some physics unit or unit that we studied in physics to actually explain the data or something without which it is not be possible. Let's say sales is given 261.96. First is it is given as a decimal value which tells it's a continuous thing, right? We can have any sales value. It can be 261.1, 261.2, and it is in USD, right? The values that are given here are all in USD. Why? Because this is data of all states of USA. You can see Kentucky, California, Florida, Texas, Wisconsin, right? So, so that's why we can say it's a continuous value. Okay. So this is how numerical values can be classified. So whenever you will get a data set, you will get these kind of values. So today we are first of all understanding data. Okay. Now we have close to 10,000 values, 10,000 rows I will say. And in those 10,000 rows, how many distinct or unique segments do we have? It is a consumer, a home office, or a corporate. You can see here, right? So we have only three distinct values in this column, right? So we can say that it is nominal. Yeah, yeah, categorical field it is. So in categorical field, when we have a categorical field, so we always have to do aggregation in order to find out distribution of data. For example, if I will ask you which one is more important for us, consumer segment, home office, or corporate, like which one has given us more profit, what will you do? You will take them and you will sum profit for these three segments, right? You will so you will apply some kind of filter here. So we can do we can select this data, press Control T in Excel, you know that, right? And it will create a table for us. And then if we have to find out for segment, so what I will do, I will just select consumer and then I will select profit and its sum, which is coming as 1,34,119.2092. So I will say for this segment it is this. Then I will do it for other segment, right? I will do it for corporate, and then I here it is less. Then I will select for home office. Here it seems more, or no, it is 60,000. So we can say in consumer segment we have more sales or more amount of sales, but someone may ask you like count of sales is also more here, 5192, right? What is the average profit value to 25? So these are all aggregate functions. Okay, we will discuss them. So with categorical fields we always deal with aggregate functions. Okay, aggregate functions are what we will study them. So with categorical fields we use aggregate functions, right, for analysis. And these aggregate functions will be what? Uh, Sum, count, minimum, maximum, average, standard deviation, variance, mean, median, mode, etc. Right? Mode. So we will see them. So these are most commonly used aggregate functions. These are only possible with these are possible with categorical values when we have to see it for every unique value of that field, right? So we can use, you cannot say that like when all consumers are there, so you can count them also, like how many consumers are there, how many corporates are there. So that is important thing. So and that's why bar chart, pie chart are created with these categorical fields more, right? In then but this type of data is what? Nominal data. Okay, what is this? A nominal data. So see, nominal is like very few, right? Here we have like we have total of 10,000 values, right? And we have total of 10,000 rows, but out of those 10,000 rows we only have 3 or 4 customers, right? We only have 3 or 4 type of segments. So here you can see the simple definition, like nominal data, categorical data used to label variables, right? Like we are labeling different orders here, that this order is of consumer segment, this order is of home office, right? And they label variables without any quantitative value or order. They don't have any order also, right? For us, consumer segment, home office segment don't have any order. Let me ask you a simple question. Okay, let's say I am doing survey and I take a sample of 10 people. Okay, and if I will ask them, what is your highest qualification? So there are only a few options which they can tell, right? What is your they can say I have passed 10, 12th, I have passed, I am a graduate, I am a postgraduate, right? I have done, or I have done PhD, not PhD, PhD, right? Some n number of only 5 or 6 or finite number of options are available, right? Do you see? So this is also a nominal data, but because if even if we ask 1 billion people, they are going to choose any one of these values, right? Or if I ask what is your blood group, right? So here also I'm going to say A positive, A negative, B positive, B negative, something like that, right? A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, etc. Right? Here also only a finite number of options are available. Do do you have any kind of order here? Like one is better than other, right? But do you have any order here like one is better than the other, right? Because companies will prefer someone who is more, you know, qualified, right? So this is called a ordinal data. This is also like a nominal data, but it has a order. For example, when you order something from a company, right? So you get options like same day delivery or next day delivery or regular delivery. Have you seen that, right? So for example, here in shipping mode, you have first class, same day, second class, standard class, right? Do you see some order here? First will be same day, then first class, second class, standard, right? So, so this will be what? This will be your ordinal data. And here, out of 10,000, we have, this is just a label, right? We are labeling every order, every sales as either it belongs to consumer, corporate or home office. So we are labeling it. When we are labeling it, that is nominal. But when we are labeling it, there is no order or quantitative or numerical value there, right? So that is why it is a nominal thing. Same goes with city also, right? Like where the order is going, or same goes with region in, or same goes with product category, whether it belongs to furniture, office supply, or technology. Do you have any order here? I don't think so, right? Like it can be anything. It can be a furniture, it can be office supply, right? So key characteristics are they have categories only. Example are gender, color, religion, they don't have any inherent order or ranking, right? You cannot perform arithmetic operations. You can't average red and blue, can you? Like, what is the average of red and blue? What will, right? What is the average of Kentucky and California? We cannot, right? And they are often coded with number for convenience, but those numbers don't mean anything. For example, when we travel in a train, right? So in a train also we have finite number of options, right? Like we have general, we have sleeper, right? We have third AC. Here third AC is, let's do AC. Here third AC is written, second AC is written, first AC is written. These are just names, right? In a numerical way, third AC will be more valuable, right? Like it's a third AC, but in actual we know that third AC is a 3 tier, right? 2 AC is a 2 tier and 1 AC is the most expensive of them. So we do have some kind of order here, but these are just names. So sometimes those numbers are used as names, but those are not. So here we have some example like gender, eye color, country, yes, no answer. Okay, so this is a nominal data. And we can also say ordinal data. I already gave you some example. So but let's ask Mr. ChatGPT. So here you can see ordinal data is a type of categorical data with the order of rank of values, but the difference between them are not meaningful or consistent. Okay, it is same as categorical, has a clear meaningful order or ranking, and interval between values are unknown. For example, in a numerical way, we know the difference between 2 and 3, right? That difference is 1, but we cannot do that numerical difference between 10th and 12th, right? Or graduate. Obviously, if we apply number of years needed to complete them, we can do that, but it is not necessarily quite evident there. Education level, like I said, customer rating, you go there and give customer rating: poor, fair, good, excellent. Surveys trail, sometimes you are asked like this, right? I strongly disagree with this, I disagree with this, I am neutral about it, I agree, I strongly agree. So ordinal data shows position, it doesn't tell you how. So what is the difference? Whenever we are creating a graph, okay, and if it is a ordinal data, so we will show in that order, right? in case of in case of a nominal data, we can show it in any order. We will see many examples, right? So that's why I'm not straight away going to just load this and start doing. We were understanding, and that's why this type of data set is very useful, because it has almost everything. It has all the recipes that we can cook, right? It has everything that we can use to create multiple type of graphs. And believe me, this is one of the best data sets available right there, because it will help you in understanding a lot of things, right? And you can write in your portfolio that I have done some kind of sales analysis. So this is how we can classify data. I hope this concept is clear. So this is first part of our today's discussion, that what are the different types of data, and on the basis of type of data we will understand. Now we will take the next step, and we will load this data in Power BI, okay, and then see how Power BI responds. And we will also cover some basics of data modeling.